Optimization, the fenced dog problem. You want to create a rectangular dog pen for your dog. You bought 60 meters of fencing and plan to use a wall of your house for one side of the fenced-in area. Find the dimensions of the pen that gives the greatest area for your dog to run around in. So step 1, draw a picture, label what you know, and use variables for unknown quantities. So let's draw our house. Here's our house, and we're going to build the fence using part of the house. So that will be one wall. So we could say, let's say something like our fence, I'll put this represents fences, these little marks here represent something that might look like the fence that we're going to build. So we're going to use 3 sides of the actual fencing material. So now what do we know? We know we're going to put fencing here, here, and here, and that we've got 60 meters. So that's the same thing as kind of perimeter for those 3 sides is equal to 60. And what else do we know? We can also label our sides. We could call that X. This would also be X. And we could call this Y, this side Y. So using the idea of perimeter, we do know that 60, or the amount of fencing we have, is equal to 2x plus y in this situation. On to step 2. You want to write an equation for what you want to maximize or minimize. In this case, if you look back to the original problem, it says find the dimensions of the pen that give you the greatest area. Greatest means maximum area, so we need to come up with an equation for area. And right there you see area, A, is equal to, in our case, area would be equal to x times y. Step 3 is to write your equation, so our equation of area, in terms of just one variable. That means we want to either eliminate the x or eliminate the y, and you'll do that by using other information that you know. And what other information do we know? Well, remember, this has to be true about our situation. The perimeter is equal to 60, which is equal to 2x plus y. Since we know 60 equals 2x plus y, and we solve that for just x or y, so I'm going to solve it for y, and y is equal to 60 minus 2x. I can now substitute this right in here for y, and now area will be equal to just x times 60 minus 2x. But always remember to think about the domain. Think about what x is if x represents this side of the house, what's the least amount of x I could have? In this case, x has to be greater than 0, else we wouldn't have any depth to our fencing area. And what's the most x could be? Well, if x is more than 30, we won't have any fencing material left. So remember here, x is between 0 and 30. Now that we have an equation to represent area, and we want to maximize it, how do we find an equation's maximum? Well, you got it right if you said step 4 is to find the first derivative and then set it equal to 0. So right here, I rearrange the equation to 60x minus 2x squared. The derivative would be 60 minus 4x, and if you set that equal to 0 and solve it, you'll get x equals 15. Now again, remember, we can do a sign analysis of this. If we substitute 15 in here, and now choose numbers on either side, and check their positiveness or negativeness. If I choose less than 15, for example, 4 or 14, right, we'll get a positive and a positive, which gives me a positive. The slope is increasing. And if I choose something larger than 15, like 16, I'll get a positive times a negative, which is a negative. The slope will be decreasing, but this does say that yes, at x equal to 15, we will have a maximum. Now, how do we finally answer our question? If x equals 15, what was the original problem asking for? It said find the dimensions of the pen. So we know the x side. How do we find the y? Well, you substitute this back into our equation right here, and if I make 60 minus 2 times x, and I make that x a 15, I will get y equals 30. So that means our dog pen needs to be 15 by 30 meters. Or, in our picture, this is 15 and this is 30.